All right, part two. So looking at continuous or discrete with quantitative variables. So these numerical measures that we have can be described furthermore as either continuous or discrete. So coming down here, continuous variable, it's a variable that can take on an uncountable number of values in a range. So in other words, the variable can be any number in a range of values. Continuous variables are usually things that are measured. So if you think about height, even though we report our height, things like, I'm like 6'4", maybe you're 5'1", you usually cut it off there at the inch, but really, you might be a fraction of an inch different than 5'1". I'm probably not exactly 6'4". So there's all these different measurements. And if you were to stand up next to a ruler with all the different tick marks in there, you could fall anywhere on that ruler, in between tick marks, any fraction of a height. So really any number is possible in between a certain range of values. And, if you think about it like pouring water into a measuring glass, well, it goes from 0 all through every possible value, every fractional value, all the way up until you fill it up to what you want. So the idea of continuous is that it can take on anything between two numerical values as well as all the whole number values that you might normally use. So the reason they call it uncountable is because there's actually an infinite amount of values between any two numbers. If you think of the numbers 0 and 1, halfway in between that is 1/2. If you do between 0 and 1/2, halfway in between there is 1/4. In between 0 and 1/4, there's an 1/8. In between 0 and an 1/8 is a 1/16. In between a 0 and a 1/16 is a 32nd. You could literally keep doing that forever and find a whole set of fractions smaller than 1/2 that are in between 0 and 1. And then you could, do from 1/2 to 1 if you wanted, and you spend the rest of your life, your children's lives, their lives, if you had time to have children while you're figuring out all these different numbers. But it's really one of these things where in between any two numbers on the number line, there's an infinite amount of numbers between them because of this idea that you can just find the halfway point all the way and keep going and going and going. You get really small fractions, but you could literally just keep doing it forever. So things that are continuous, as an example here, height, weight, volume. If you're looking at, a liquid, volume of anything really that you're measuring, but, if you think of a volume of a liquid, like volume of water, that's going to be a continuous measurement. You can take on any value as you're measuring it. Temperature, we don't just go from, 30 degrees to 31 degrees. You pass through all the fractional values in between as your temperature is increasing. Time, every split second of time can be measured. And, even though I say, it's 2 o'clock or it's 3 o'clock or 2:30 or, it's 2:01. Well, in between 2 and 2:01, there was a bunch of seconds. And in between each second, there's a fraction of a second, So all these things are continuous measures, anything that can take on any value in a range. Whereas on the other hand, discrete variables, it can only take on specific values in a range. So it won't take on all of them, only specific ones. And these are usually things that you're going to count. So like if you're going to go out and count rocks that are in your front yard, you're going to be like, there's 1 rock, there's 2 rocks, there's 3 rocks, there's 4 rocks. You're not going to be like, there's 1.5, there's 1 3/4 rock. You're not going to do that. You're just counting the rocks in the yard, and you're using the whole numbers, counting numbers to do that. So, examples, number of rocks in the yard, amount of ice cubes in a glass. Things like that. And a lot of times they'll do what's called discretize numbers. Like when you give your age, you don't say things like, I'm 48 years, 9 months, and 7 days, and 4 hours, and 32 seconds, and fraction of seconds old. Nobody's going to want to hear that. You just say like, I'm 48 years old, and then you move on. So they'll discretize the number. They won't go out to all the fractional accuracy that the normal continuous value would have. So if you ever hear that term discretize, that just means they took a continuous value and chopped it down to something more reasonable to deal with. Okay, so to finish out this section, we're going to look at some examples here to give you some practice on the terms before you get into the homework sets. And let me see if I can, there we go, oops, went too far. So in example 1, what I want you to do is pause the video and try example 1 on your own before you come back and see the answers. So pause. Okay, so hopefully you paused and tried those. It's hard for me to know over here as I'm making this, but the height of measurements of an entire NBA or roster of NBA players, and we want to determine if this is going to be a population or a sample. And the height measurements of an entire roster, anytime they give you a clue that it's all of something, that's really the dead giveaway that this is going to be a population. So if they didn't say the entire roster, you wouldn't be able to assume it was a population, but the entire roster is going to be the population. And then the amount of gas in 15 cars are selected from a car rental lot. Well, we're going to assume that there's more than 15 cars on this lot. So they don't tell us that, but we're going to have to assume that. And that's something that you'll do a lot of times. Car rental lots are usually pretty big. They have, especially if you go down to like the airport down in Phoenix, you're going to see hundreds of cars out there on the rental lots. So taking 15 from them, you can pretty much assume that that's a random sample or some sort of sample. And then the word selected too kind of gives a little key. You're just selecting 15. Otherwise, you're going to say the amount of gas in all the cars on the rental lot. So when they say this idea, the word selected is kind of like giving you this idea that it is a sample. So this would be a sample. All right. So example 2, I want you to again pause the video and come back, and I'll start going through the answers. So pause. And welcome back. So we're going to determine whether each variable is quantitative or qualitative. And if it's quantitative, we're also going to decide if it's continuous or discrete. So if it's qualitative, we just stop. But if it's quantitative, we got to go that one extra step and classify it further. So the height of a tree. Well, if I measure the height of a tree, it's going to be with numbers, some sort of measuring device with numbers on it. So that is definitely going to be quantitative. And heights are continuous. I could get any little fractional measure in between those whole number heights on my measuring device. A child's favorite cartoon. I don't know a whole lot of cartoons that just have numbers as the name, and really if you're adding together cartoon names, even if they were numbers, it's not going to be meaningful. So when you ask a kid what their favorite cartoon is, they're going to answer in words. So this is definitely going to be qualitative. The number of cars in a parking lot. As soon as you see that number, that's pretty a pretty telltale sign that you're looking at quantitative. So, and if you go out there and count the number of cars, you're getting numbers from that. And if you add together the numbers, they will have meaning. So quantitative for sure. And if you're counting, you're not going to, say like there's half a car, it's either going to be 1 car or 2 cars or 3 cars. You're not going to have half cars, 3/4 cars. Even if it's a bigger car, you're not going to say, ooh, that's 2 cars in 1 or 1 3/4 cars. So it's a second car or something. So this is going to be discrete. And then a person's phone number. So you might think number, oh, it's quantitative. But this is where you got to really be careful. Just like the area code, it's a quality of a region. It has nothing meaning, no meaning to it if you try to add these things together. Like phone numbers, if I took 2 people's phone numbers, added those together, it may not even be a real phone number anymore. If you start carrying numbers around, it might not even have the right number of digits in it anymore. So phone numbers definitely are not quantitative. They're a quality of a person. It's something attributed to you. It's like social security numbers, also quantitative. So anything that you're kind of in debate with, it's like, okay, if I add these together, will they have meaning? In this case, phone numbers will not, and this would be qualitative for sure. And then the last one here, satisfaction survey uses numbers 1 through 5 for answers. This is also going to be something that is qualitative, because if you're looking at your satisfaction where it's like strongly agree, mildly agree, indifferent, mildly disagree, strongly disagree, those things that get these numbers 1 through 5 attached to them, you're really basing those numbers on a quality of how you feel. So any survey that uses numbers for the answers, where the numbers are representing qualities or feelings, this is going to be also qualitative. So the last 2 there are ones that have numbers in them, but are not quantitative because they are not measuring something as you typically would with numbers. Okay, so hopefully that helped you get a little better understanding of the terms that we looked at in this section, and we'll pick up in 1.2 in the next video.